Hello everyone and welcome back. Today for lesson 13, how to solve a quadratic function by completing the square part 2. Remember this is only the second part of this and then we'll be done with that and moving on. Did just want to make a little comment today. I thought I would braid my hair, try something a little bit different, and then it didn't look as nice because it's hard to do on my own head. So I put a bandana on, or headband on, and then I looked in the mirror and thought I looked like this fella here. Do any of you know who that is? Willie Nelson, ladies and gents. So we are twinning today. Anyways, we're going to solve by completing the square when your leading coefficient is not 1. So in lesson 12, we solved quadratic functions when our leading coefficient was 1. So remember, completing the square, we factored into perfect square trinomials because then it made it possible for us to use the square root method to solve that quadratic. So we're doing the same thing today, except there's one additional step since your leading coefficient is not 1. So if your leading coefficient is not 1, if you notice in the first example, it's 3. Well, it's quite simple. All we need to do is make it 1. So if we had 3x squared, how would we make that have a leading coefficient of 1? Well, we could divide it by 3. But this is an equation, and so technically we're not just dividing the first term, we're dividing every term by 3. And also, whatever you do on one side of the equation, you have to do to the other. So when you're solving a quadratic using the completing the square method, and your leading coefficient is not 1, make it 1 by dividing by whatever the leading coefficient is. So we are going to divide every single term by 3 on both sides of the equal sign. So the first term becomes x squared. Notice the leading coefficient is now 1. That's what we want. And then negative 6x divided by 3 is negative 2x. Oh, I did forget. I worked through these just to make sure that I didn't have any issues like before, and we will. So we want to make this into a negative 12. Okay, so negative 12 divided by 3 is negative 4, and then 0 divided by 3 is 0. So we are changing that to a negative sign because if we didn't, it would give you an imaginary answer. When I made these notes, I thought maybe we would get to that and be able to handle them, but there were different plans there for that, so we're just not going to worry about the imaginary numbers. So change that to a negative sign, and now we can complete the square like we did in the previous lesson. It's the exact same thing. So if we look carefully, it looks like it is a perfect square trinomial. 4 is a perfect square, this is a perfect square, but remember that middle term, if you take half of b and square it, that was finding the c value. Hang on, it's loading here. Those blanks. So c is half of b squared. So if we were to do that with this example, we have 2, and half of 2 is 1, and 1 squared is 1. That is not a 1. That is a 4. So since that's not a 1, this is not a perfect square trinomial. It looks like it because that's a perfect square, but it's not because of that middle term being a 2. So we still need to move that 4 to the other side. So we're going to set it up to complete the square. That was the first step there. Or actually, this is the second step now that we've incorporated this new first step. So setting it up to complete the square, x squared minus 2x plus the c value that does make it a perfect square. And then we're going to add that 4 to both sides. So we've got 4 plus that same blank, okay, that c value. And how do you find c? You take half of b and square it. So we've got 2 divided by 1. Nope, just kidding, half. Half of 2 divided by 2, which is 1, and 1 squared is 1. So we're plugging in 1 for our blanks. All right, the next step was to factor the left side and simplify the right side. So the left side factors easily because we just made it a perfect square trinomial. So that factors to one bubble that's squared. And if you recall, it's the square root of the first term, the first sign, and then the square root of the last term or half of the middle term. Either way, it's going to be 1. And then simplify the right side. 4 plus 1 is 5. Now we've just completed the square. The very last step was to solve using the square root method. So this part that's squared is by itself. So we can now square root both sides. So the square and the square root cancel each other out here on the left. So we have x minus 1, don't need parentheses, equals. On the right, we're taking the square root of a number, so don't forget your plus or minus. So plus or minus the square root of 5. The square root of 5, does that have a perfect square factor that we can divide out to simplify? 5. Can we divide any of those out of 5 other than 1? No. So that is already simplified. Excuse me. And so that radical part is done, and now all we need to do is get x by itself by doing the opposite. So it's x minus 1, so add 1 to both sides. So add 1, and remember, this is a radical, this is not, so they don't combine. So we just have a positive 1 plus or minus the square root of 5, and you're done. See, that wasn't so bad. Just a quick recap. We started out with a 3 as our leading coefficient. So in order to complete the square, we want it to be 1. So we divided everything by 3. And then leading coefficient was 1. This 4 was not making it a perfect square trinomial. So we moved it to the other side and made way for the c value that would. Found the c value, plugged it in, factored the left side, simplified the right, square rooted both sides, and got x by itself. So there's that one. We're going to do example 7 together, and then you're going to do example 8 on your own. Again, with number 7, we want to change this plus 30 to a negative 30 so that we avoid an imaginary answer. Excuse me here. Excuse me. Okay. All right, so again, example 7, 5x squared minus 10x minus 30 equals 0. Oh, I didn't want to do that. There we go. Oh, okay. Make it look like a subtraction sign. Okay, so in order to get a leading coefficient of 1, we have a 5 currently, so we need to divide every single term by 5 on both sides of the equal sign. And then what we get is x squared minus 2x minus 6 equals 0. Boom. Now this is just like lesson 12. X squared minus 2x minus 6 equals 0. Is this 6 making this a perfect square trinomial? No, because 6 is not a perfect square. So we want to move it to the other side and make way for the c value that does. So x squared minus 2x plus the c value that does make that a perfect square equals, and then we had to add this 6 to both sides. So we have a positive 6 plus that c value that does make it a perfect square trinomial. So what is that c value? Well, how do you find c? Take half of b and square it. So this b value is also 2. So half of 2, if you have 2 of something, you cut it in half. You each get 1. So 1 and then 1 squared. Well, 1 times itself is 1. So again, our c value is 1. So we're going to add 1 to both sides. And now we can factor the left side and simplify the right. So factor the left side, 1 bubble squared. Square of the first term is x, the sign is subtraction, square of the last term is 1, and then 6 plus 1 is 7. Now we can solve using the square root method. Square root both sides. Here the square and the square root cancel each other out, so we have x minus 1. We're taking the square root of a number, so we get plus or minus the square root of 7. Square root of 7, does that simplify? No. So now we just need to move the 1 to the other side. So add 1 to both sides. And then we get x equals 1 plus or minus the square root of 7. Okay. Those two were very similar. And of course, example 8, the one I'm asking you to do, has a little bit more to it. Alright, I'll do 8 with you as well. So make sure you're dividing everything by 3. Why did it just do that? And you get x squared minus 4x plus, 16 thirds. 16 divided by 3, ew, fraction, ew, decimals. You could say that's 5.3 repeating, or you can just leave it as 16 thirds. Either way, that is not the c value that's making this a perfect square trinomial. So we are going to move it to the other side, make way for the one that will. So we've got x squared minus 4x plus c equals, we need to subtract that 16 thirds from both sides. So minus 16 thirds plus the c value that does make it a perfect square. How do you find the c value? Take half of b and square it. This time our b value is 4. And so half of 4 is 2. 2 squared is 4. And so then we can factor the left side, simplify the right. So we get x minus 2 quantity squared equals negative 16 thirds plus 4. Is negative 1.3 repeating or negative 4 thirds? Oh, it's negative. So since this is a negative, I did not think this one all the way through. That's going to give us an imaginary answer as well, but I can at least just show you what would happen. Again, this isn't anything that I would expect you to do on your own. This is more Algebra 2, but it never hurts to kind of learn in advance, right? So we could square root both sides. Square root both sides. Taking the square root of something that's squared, so they cancel each other out. Square root of a number, so don't forget your plus or minus. Negative 4 thirds. What we would have to do is we'd have to take out the imaginary component, which is the I. So the square root of negative 1, we have talked about that a little bit. Square root of negative 1 is equal to I. So in order to take out the imaginary component, what this would look like is x minus 2 equals plus or minus I times the square root of 4 thirds. I'm running out of space. So that's taking out the imaginary component, and then the square root of 4 thirds could be simplified. There's a lot going on with this one. This would be like a super bonus if I ever gave it to you. So we could simplify the 4 thirds. We know how to do that. We did it in chapter 7. That would be the square root of 4 over the square root of 3. And then we would have to rationalize the denominator. So multiply by the square root of 3 over the square root of 3. and we get the square root of 12 over 3. And then we would have to simplify the square root of 12. Just copy this one down. So then the square root of 12 has a perfect square factor of 4. So we have the square root of 4 over the square root of 3. Looks familiar. Over 3. And then the square root of 4 is just the same thing as 2. So we have 2 radical 3 over 3. Woo! Not to mention that there's an I in front of all that. It's imaginary. And my personal preference is I like to keep the I right next to the radical because that's where it came out of. So I could do that. I'm going to rewrite it, but also we have to add this 2 to both sides. So your final answer is x equals 2 plus or minus 2i radical 3 over 3. Ew, that's a crazy looking number. But it's a number nonetheless. It is a complex number because it has a real component and an imaginary component. But again, don't worry about this example. It's very in-depth, very over your head right now, probably, not to mention you're teaching yourself math at home, and I go kind of fast on here. I get that. So don't worry about example 8. Don't expect me to give you anything like that. Actually, what I'm going to do is if you watch these videos with me, you're lucky. I'm going to erase that one and not require you to do it, but require you to do number 7. So when I upload the key, this one will be blank. But if you followed along with me on here, you got it all down. So there's a free one for you. All right, number 9, I do want you to try on your own, but I'm going to do number 10 with you first. This is just writing a quadratic function from one form to another. We did that before when we factored. Okay, so if I gave you a trinomial and I said to factor it, you're going from standard form to vertex form. If I go all the way back up to the top of your notes, this is your vertex form, so that's the factored part. And then here would be your standard form. That's like a trinomial that you had to factor. So now we're going to, or even intercept is like a factored form. All right. My dog just farted and it smells. Oh. By the way, nobody's guessed his name yet, so I might just tell you in this video. All right, so we're starting out with standard form, ax squared plus bx plus c. And we're going to go into vertex form, which is y equals a times the quantity x minus h squared plus k. Did you get that? All right, basically we want a bubble square. So we're just going to have to complete the square. The 68 is not a perfect square. The only thing that's slightly different about this, oh my goodness, it smells so bad. Okay, is we want to keep y by itself. So normally we would like move that 68 to the other side. You still can, but you can also just kind of move it out to the far side because we don't want that there. So y equals x squared plus 26x plus the c value that would make that a perfect square trinomial, because we're trying to make this into a bubble squared, trying to do that, plus the 68. But if we add this blank to this side of the equation, we're going to have to add it to the other as well. So I'm going to leave a y plus blank here. Okay, so what would that value be, that c value, to make this a perfect square trinomial? We're not worried about the 68. So 26 is our b value. Half of 26 is 13. Do you remember what 13 squared is? It's 169. So this is what we've got going on now. We're adding that c value to both sides. So y plus 169, I'm just going to leave that there for now. equals. This is where we can now factor that. So this part right here is what we just made into a perfect square trinomial. So that part right there factors. And what it factors to is an x sign plus sign, square root of the last term, 13 squared. Okay, and then we still have that plus 68 chilling there on the end. Now the only thing that we need to do to get y by itself is subtract 169 from both sides. So this kind of bubble squared part is going to stay as it is, and we're just subtracting the 169 from the 68. So minus 169 minus 169, 68 minus 169 is negative 101. So we get y equals x plus 13 quantity squared minus 101. And so then there is our y equals a times x minus h quantity squared plus k. That's vertex form. We just don't have an a value. Where you might have an a value would be if, oh, I don't think this one is like that. Nope. You might have an a value if your leading coefficient was not 1. So if you would have had to divide by a certain value to make your leading coefficient 1 so that you could complete the square, then you might have an a value. But in neither of these you will have an a value. So there's your answer for that. And I want you to try. So attempt, example 9 on your own. Okay? So there's that. I also just want to make a quick note. You should be copying these notes down. Okay, you're going to be graded for just copying them down. And then you're also going to be graded for attempting the examples. Okay, you need to be showing me that you're trying the examples. Do I expect you to get them all done perfectly? No, of course not. Like, we're not in the classroom. I don't know how you're doing. I'm getting very little feedback from you guys, but I do need you to be copying the notes down and doing the examples that I'm highlighting in yellow. Okay, you need to be attempting them. You're graded on both. I don't want you to super stress out about these though. Like, this is a tough chapter to do in the classroom, let alone on your own from YouTube videos if you are even watching them. You are, if you hear this. So please, please, please just do your best. Know that I miss you, and I hope that you're learning something, just a little bit. That's what I want you to get out of this. But just know that I understand if you're struggling. So there's that. And here's my dog. Ooh, sleep farting. Oh, he's so sleepy. Oh, so sleepy. But I did name him Tucker. I've been calling him Tuck for short. So he's been keeping me company, but growing like a weed. If you go back to the first video, I introduced him to you guys. He's so sleepy. Oh, look at that. But he's learning some math along with you. Okay, hope you guys are doing well. I miss you. I can't wait to see you again sometime in the future. Bye.